Probably the most well-known thing in all geometry. If people know one thing from geometry, it's usually the Pythagorean Theorem, which will say that the square of the hypotenuse is equal to the sum of the squares of the legs. In other words, c squared equals a squared plus b squared. Okay. Now, two key things here. Number one, notice that it says in a right triangle. In other words, this only works for right triangles. This only works for right triangles. So we'll be talking next week about what happens when it's not a right triangle. But right now, no, this only works for right triangles. All right, that's thing number one. Thing number two is that you need to make sure that you know where the hypotenuse is. So I talked about this yesterday with the people who came to the Zooms yesterday, that the hypotenuse is my longest side in the triangle across from the right angle. So that's going to be a key thing to know, is where the hypotenuse is. Because that's always going to go, in other words, be my C, and it's going to go on the left side of the equation. So that's how you tell what C is. And then the legs, the A and the B, are going to go on the right side. So picking out the hypotenuse is the first thing we're going to be doing on each of these problems. Let's look at an example. First one. We'll start with a fairly straightforward one here. Our hypotenuse is going to be, we're going to look across from the right angle, and that would be this side. Another way to see it, if you have trouble seeing it that way, is I'm standing right here. Here's my right angle, so I'm standing right here. I look across from that right angle, and there's the side I see. So that's my hypotenuse. Another way you can find it is by process of elimination. It's saying, well, my two sides that build the right angle are the legs, and so the last side has to be the hypotenuse. So I'm going to build my right angle. One side, two sides, there's my legs. So this other side that I didn't trace out has to be my hypotenuse. Either way, this is my C in the C squared equals A squared plus B squared. So the 5 is going to go on the left side. And on the right side, we're going to put the 3 squared plus x squared. And then we'll work those out. 5 squared is 25. 3 squared is 9. I want to get x by itself, so I'm just going to subtract. (25 minus 9), that's going to be 16. So if I've got x squared and I want to just get x by itself, then to undo squaring, I'm going to take a square root. Square root of 16 is 4. So 4 is my third side. right angle. Right across from it, that's my hypotenuse. Or, here's my two legs I used to build the right angle. So the other side has to be the hypotenuse. So x squared is going to go on the left side. And then my other two legs are going to go on the right side. I've got 4 squared plus 6 squared. So let's add those together very quickly. 4 squared is 16. 6 squared is 36. That is 52. And so we're going to undo squaring by taking the square root of both sides. All right. I'm going to teach this next part as if it's brand new, because the last time we talked about it was all the way back in chapter 1 when we did the distance formula, which also involved square roots. We're going to talk about simplifying a square root. So the technical name for this is prime factorization. That's the technical name for what we're about to do. I'm going to call it building a tower. So I'm going to put 52 at the base of the tower. And hopefully this starts to ring a bell when I start to talk about it again. So 52 is at the bottom. We are going to start by dividing by the smallest number that we can. Well, dividing by 1 isn't going to do anything, because anything divided by 1 just loops back on itself, and then the tower never ends. So we'll start with 2 and see if we can divide that number by 2. And we'll keep dividing by 2 until we can't divide by 2 anymore. And then once we can't divide by 2 anymore, we're going to see if we can divide by 3. And we're going to keep dividing by 3 until we can't divide by 3 anymore. And then if we can't divide by 3 anymore, then we'll keep going until we divide all the way down to hitting 1, which will be the top of our tower. So let me show you how that works. So in this case, we can divide by 2. And if we divide this by 2, we're going to get 26. And we're going to see if we can still divide by 2. Can we still divide by 2? Yes, we can still divide this by 2. And we get 13. Can we still divide by 2? Nope, not anymore. In fact, we can't divide this by 3 or 4 or 5. This number we can't divide by anything except itself, 13, and hit 1, top of the tower. So 1 marks the top of our tower, and we are going to, the next step in this process is going to be to circle any of our pairs. So in this case, we got a pair of 2s. And if I have a pair can go outside of the square root. So we have a 2 that is left outside of the square root, that is brought outside of the square root. But the 13 doesn't have a pair to go with it. It's by itself, so it has to stay inside the square root. The way that I showed this for people to remember what order this goes in is that couples can go out, but singles have to stay in. So if there's a pair to go with it, then they're a couple, they get to go out. They get to come outside the square root. Single, oh, it's all by itself, it's lonely, and it's got to stay inside. So the 13 has to stay inside the square root. The pair of 2s have to go out. Now, here's mathematically what's going on. when I circle these pairs and bring them out, what's happening is that I'm saying that I'm rewriting 52 as 2 times 2 times 13, right? That's how we divided, so I can multiply back and get to 52 again. And what happens with this pair sorry, 2 times 2 is 4. That's what I'm thinking. Is that I get the square root of 2 squared times the square root of 13. That's another way I can write that. And what happens is that with a pair, if I'm multiplying something twice, that's the same as squaring it, and all of a sudden I have what's called a perfect square. In other words, this is a 4. That's another way to think about it. And so when I take the square root of 2 squared, they undo each other, and I just have a 2 out here, square root of 13. That's what we're really doing mathematically, is that this pair will create a perfect square of 2 squared, because I can rewrite 2 times 2 as 2 squared, and then the square root and the square undo each other, and I can make the 2 be outside the square root. That's mathematically what's going on. Is the square root and the square undoing each other. So anytime you see a pair, that'll create that perfect square that I can bring outside the square root. So pair of 2's means a 2 goes outside the square root. The 13 is going to stay inside the square root. So final answer is 2 square root of 13. Let me give you another one to try to work through understanding this process. So flip to kind of the back page, and we'll do 1 or 2 of these as we go along here. As a matter of fact, I'm going to have your homework this week be just practicing a couple of these square roots and making sure that we know how to simplify them, because we're going to keep, this is going to keep coming up going forward. It's simplifying these square roots. So instead of 52, let's try 54. I'll give you a minute to build that tower and see what you come up with. We'll start by trying 2. Oh, we can divide by 2. Can we still divide by 2? Nope. Can't divide by 2 anymore. But we can divide by 3. Is the next number we can divide by. Can we still divide by 3? Yeah, we can still divide by 3. 3. Can we still divide by 3? Sure, we can still divide by 3. We get 1 top of our tower. Let's see what pairs we have. Oh, I've got a pair of 3's right here. I don't care about 3 of a kinds. I do care about pairs. And this is a 3 and a 2, and don't match. And so I have a pair of 3's. So a 3 is going to come outside the square root. Inside the square root, I got a 3 and a 2. We're going to multiply those. So left inside the square root is 3 times 2 is 6. So this is 3 square root of 6. So questions on that? Again, I'll give you a few of these to practice for homework to make sure that you know how these work. All right. let's move on. Let's move away from all the square root stuff for a little bit and talk about TVs. A television screen measures approximately 15.5 inches high and 15.9 inches wide. A television is advertised by giving the approximate length of the diagonal of the screen. All right, let's draw the diagonal. There's our diagonal. And we are measuring 15.5 inches high, so let's draw out our height. And then it says we are 19.5 inches wide. Okay, let's draw our width. 19.5 inches. Oh, look at that. It's a right triangle. What a coincidence. It's almost like we're in the chapter about right triangles. Extraordinary. We want to know this diagonal. Which will be the hypotenuse. So let's take a look here. Our hypotenuse is what we're trying to solve for here, right, across from the right angle. So an x squared is going to go on the left side. And then over on the right side, we're going to get 15.5 squared plus 19.5 squared. And since the problem gives us some decimals, I'm going to say that we're not going to be too worried about simplifying square roots or anything like that. Let's keep it working with decimals. So sometimes it'll want the decimal, sometimes it'll want that exact answer with the square root. It'll just depend on the problem. If I take 15.5 squared and add 19.5 squared, that's what I get. So let's take square root of both sides. I believe that comes out to about 24.9 inches. All right, we're advertising a product here. So first of all, if we're advertising a product, the consumer doesn't want to see decimals. So let's give it a whole number. And you know what? We want to market up our TV a little bit, so let's round up. And let's make it sound extra nice here. Ultra HD. Let's see. You've heard of 4K. How about 16K? Deluxe. And we'll put an exclamation. All right, now we're advertising. Questions on that problem? So again, the key part of these is picking out where the hypotenuse is, because that determines what is going to go on the left side and what's going to go on the right side of the equation. That's the really important piece here. All right. I'm going to end here by giving you one more problem to try. And this one's an all-time classic. I feel that I would be depriving you of the true experience of geometry if I did not give you a problem where a ladder is leaning against a wall. So here it is. So I want you to work on that. And I want you to, first off, pick out what the hypotenuse is. And see if you can get an exact square root as an answer. And the decimal. So see if you can give me the answers in both forms here as you're working through this.